Hi everyone, my name is Jim Bashirs. I'm a field applications engineer here in the US and the CTSS for inductive, capacitive, and magnetic sensor products in the Americas. I'd like to thank you for watching our video on the Pepperl-Fuchs Safety Guard monitoring system. We will be going over the hardware, its capabilities, and a little history about the product. So if you have any questions about the system, please contact our tech support team here at Pepperl-Fuchs. Okay, let's begin. Okay, how many of you have ever had a potato chip? All right, I know we all just can't eat one. Lay's are my favorite. We used to have a really large plant here in Chicago. I think pretty sure it's closed now. So we all know a potato chip is a potato cut into very thin, repeatable slices and then fried. Consistent thickness of the chips is crucial so that they cook properly. Unless they're handmade, most companies cut potato chips on a machine you will see an example of later on. And a kind of interesting fact, potatoes are very corrosive and they're really abrasive to machinery. You can imagine the process requires potatoes to be fed in huge amounts through the system. And the machines that have to be taken offline and rerouted to a parallel system every few hours, I think it's like 4, just to change knife blades. So if you had cheese on a pizza, either shredded or chunked, cheese can get really clumpy while cutting and clog up a machine unless it's operating at high speeds, just like those associated with size reduction machinery that you would find in the food industry. Okay, how about diced vegetables or meats? They go pretty good on a pizza also. Most of the frozen and canned vegetables, salads, anything that's not hand processed is probably done on a machine with the safety system. How about peanut butter? Some of the machines used to make peanut butter and Nutella are guarded with the P&F safety system. Even though we're taking a hard nut and making a creamy food from it, it's still made from the same type of machines that make potato chips. Medicine, I know we all take medicine for something. Machines that pulverize ingredients to make a powder are guarded by the P&F safety system. So all of these products that touch our lives pretty much every day and a lot more are made with what is known as size reduction machinery. And most of those machines are guarded by a P&F safety system. So here in this picture, you can see P&F's original and current model monitor and the sensors. So for a little history, the safety monitor system was acquired in 2000. This system was originally designed for food machine applications. A system was needed that would shut down a machine if a protective panel was loosened or removed, preventing an operator from injuring themselves on spinning knife blades, motor drive belts, or other dangerous parts, moving or not. So when P&F acquired the system, it did not have any safety approvals. Our engineering group in Twinsburg at the time did all the investigating and testing of the device, and then they submitted it to UL. We ultimately received a rating of Cat 3 and performance level D. The original monitor took up a lot of room in a control panel and was 120 volts AC only, which when it was designed was fine to use. Since then, controls have improved and users have a desire to remove any, potentially high dangerous voltage off the control panel devices. A lot of areas in food processing are high humidity and standing water is abundant in a plant. Keeping high voltages off control panel devices like push buttons and selector switches makes the working environment safer. The monitor was changed to run on 24 volts AC DC and a DIN rail mountable version to make it smaller. Sometime after that, the sensors were redesigned to give them a better look and more safety features. Some highlights of the system as a whole. The monitors use a PNP and an NPN input per channel. The sensors are configured to supply that signal. The ratings for the device are dependent on using the 50FY series sensors. Both the original and the current monitor can use the older or current sensors but you cannot mix actuators and sensors between revisions. As a system, the monitor and sensors have CE and CUL-US ratings. Up to 6 safety sensors can be monitored. The sensors are internally ANDed to provide control for the safe output relays. There are no other reset inputs or unsafe monitoring outputs available. Any unused channels must be fitted with a simulator model or 22K resistors. To reset the monitor after a fault, the monitor power must be cycled on and off. Since the sensors are usually hidden in the machine, having a status indication on the monitor is a must. It saves troubleshooting time for a guard fault by knowing which guard was removed. Since the majority of applications for this product is in food processing, making a stainless steel sensor that harbors less bacteria accumulation sites is a really important feature. It's estimated that a company with a major recall that caused sickness or death takes about 3 years to, or even more, to recover from. So the sensors being able to be cleaned are really, really important. Let's compare the two monitors. Since they are installed in a high humidity environment, they're both sealed with conformal coating silicone resin. Which kind of a funny story. We've had stories with the original monitor of maintenance people that were told to power wash a machine, and they thought it was okay to include this inside of the control panel. And the older FYQLA1 version survived with no damage. As we discussed earlier, the monitor has indicating lights for each channel to facilitate troubleshooting a machine. The monitor is typically mounted behind a glass plate in the machine control panel so operators or techs can see the LEDs easily. The KE5D2 is easier to install on a DIN rail, and it makes for a more modern look to the machine controls. The FYQLA1 model runs on 120 volts AC. The KE5D2 model runs on 24 volts AC or DC. The 120 volt AC version FYQLA1 model has been in use since 1994. So there was a push to lower control voltages on machines to make them safer, and that resulted in a redesign to the KE5D2 monitor in 2013. As we said earlier, these machines are primarily used in food processing where there's a lot of water and humidity. Lowering the panel control voltage to 24 volts AC or DC makes the whole system safer for operators. Both monitors are designed to accept up to 6 of the original or the new 50FY series sensors. Any unused channels must be terminated using 22K ohm resistors and sealing grease, which is the case with the FYQLA1 monitor. The grease prevents water short-circuiting the sensor inputs and causing false trips. A SimMod sensor simulator is used instead of the 22K resistors. It came out with the KE5D2 monitor. It's basically a small block of plastic with pins on it and the 22K resistors encased in it. And again, the system is certified for Cat 3 or Performance Level D. The input channels on the monitor accept a PNP and an NPN input. Both are contained in the 50FY sensor. Since a majority of modern safety devices provide PNP outputs and not a mix of PNP and NPN, the monitor must be used with the 50FY series safety sensors. There are 2 force-guided, internally connected safety relays that provide the output on either monitor. On the older monitor, you can see them in the top right corner. Because of the PNP-NPN output configuration, PNF offering for sensors is limited to the 50FY series magnetic safety sensor. You can see here the wiring of the KE5D2 system. The 2 force-guided relays are linked together in the monitor to provide safe output. The color coding of the sensor cables is a little bit different than the European coding we're all used to. The colors used are red, white, black, and orange, left over from the original design. What you don't see on the monitor is a non-safe reset input or a non-safe monitoring output. They weren't in the scope when the monitor was redesigned due to time issues. Resetting the monitor requires a power cycle. Our original sensors were made with polysulfone shells for food grade applications, and you can see them on the left. The actuator magnet was not keyed, and this was changed with the stainless steel version of the sensors. They have cabled connections. No version with connectors or pigtails are available. The polysulfone model sensors were canceled after the materials ran out, so those are not available anymore. As stated before, the sensors have one PNP and one NPN output. So the old sensor was not magnetically keyed. In the revision, the keying function was built into the new sensors. Since the sensors cannot be mixed, you can't take an actuator from one type and use it with the sensor from the other. P&F provides a kitted part number that includes a sensor and a target to make it easier when replacing a sensor. As stated before, stainless steel sensors and the actuator provide a better looking, modern, and more rugged sensor package. So here's a little size chart. The actuator comes in a pretty compact package. It's 39 by 39 by 12.7 for the sensor, and the same shell is on the actuator, so the actuator is the same size also. The sensor will turn on at 2.5 millimeters and turn off at 10 millimeters, and we do that to prevent vibration from causing false tripping. Actuation distance can change with horizontal offset between the sensor and the target. For example, at 3.5 millimeter offset, the sensor will actuate at 1.3 millimeters instead of 2.5 millimeters, and at 4 millimeter offset, the sensor won't even actuate. It doesn't pick that up at all. For applications requiring hazardous area use, the sensor and the monitor has been rated for use in a Class 1 Div 1 Groups A, B, C, and D area. The rating is good when you use P&F barriers model number Z715s and the Z715F. And cable length ratings must be adhered to. The sensors may be installed in a hazardous area when it's wired to the Zener barriers. Barriers must be installed in a safe area. From there, they are wired to the monitor. So these go in between the sensors and the monitor. So for applications, the system will work really well on machinery that has multiple doors or gates that you need to monitor. If you have a machine with removable guards, the system works really well. Since the monitor will take up to 6 sensors and provide one output, it will save some inputs on a safety PLC or other type of safety system. Machinery with any type of rotating blades, crushing machinery guards, hammer mills, or chemical mixing that requires mixers or high energy makedown processes like those that are used in the water treating industry, this system would be good for. Multiple entry gate systems to a machine area would be a good application. Up to 6 gates can be monitored. So here are some examples of size reduction machinery for the food industry. We talked about these a little bit earlier. A typical knife ring is shown on the left. The machines of this type typically have product fall into the top, and the resized product flows out the bottom to either a conveyor for further processing or into a bin that is swapped out when the bin fills up or at regular intervals. The machine on the right is showing the basic configuration. A modular knife set and guarding attachment would be installed horizontally on that spindle. You can see on the third from the left machine the yellow cabling for the sensors, and the window, the monitor, is mounted behind for easy viewing is kind of shown there. So here's my favorite, the potato chip slicer. It works a lot like a garbage disposal. The potatoes fall right into the top, and they're spun against the knife ring with centrifugal force at really high speeds. The blades can either be straight or ripple cut or any other kind of cut that they would like. We talked about this a little earlier, but the machines have to be taken offline to change the blades in the cutting ring about every 4 hours due to the abrasiveness of the potatoes. This type of machine is used more for cheeses, meats, vegetables, to make diced or julienne products, that kind of thing. On the right side of the machine is a conveyor that forces the product through a series of blades for horizontal, vertical, and dice cuts, all in the same machine. the finished product falls through the discharge chute to either a conveyor or a bin, like the potato chip machine. So that's all we have today for the safety monitoring system, and I'd like to thank you for watching. And if you have any questions, please contact me or one of our tech support people here at Pepperl-Fuchs. And thanks again, and have a great day.